I'm going to title this video something a little different. I'm going to call it Statistical Soul. I want you to kind of understand, and through by way of example, we've already, if you're watching this particular video, we've already covered, and you've already watched the videos on the intro to measures of central tendency. You've watched the video on mode, median, and mean. And you know that they're supposed to kind of converge on the same point if you have a normal distribution, but I want to give you a scenario and show you how the two, or at least two of the values, I'm going to specifically or show an example of the median and the mean, how they might not give you the same central point, and how one might be more representative of what's actually going on with your data than the other value. So let me just kind of show you the example here. So let's just, I'm going to kind of lay this out for you. Let's say you had 100 families in the Hattiesburg area. Let's just say it was in a Hattiesburg, let's just call it a development, like a home, a neighborhood, some kind of housing development. Whatever the development is, this is fictitious. I'm making it up. And out of those 100 families, 99 of the families have an annual family income of $100. Now, I know this is a ridiculously low value, but I'm doing this just to kind of illustrate a point here. And all of those 99 families have the same $100 annual income. And then one of the families, has an annual income of $90,100. Certainly, at this point, you're already thinking, wow, this is an extreme case. It must be some kind of, outlier. Let's look at the mean family income. So, we know the equation here, but essentially, what would we want to do? So I can do the math here simply by myself. You take the 99 families and multiply that by 100, which would give you, it's 99 times 100 would give you $9,900. And then you add the last family in that has the annual income of 90,100. So you take 9,900 plus 90,100, and you're going to equal 100,000 for your numerator piece. So if I take this to get the mean, then I'm just working my math out here. To get the mean, I'm going to take that, so my x bar is going to equal $100,000 divided by 100 total families, which would give me $1,000 as my mean family income. So this value right here, the 1,000, is equal to my mean family annual income. Okay. What's interesting is no family other than the one has an annual income that's even close to 1,000. In fact, that would be 10 times more than the other 99 families that have an annual income of 100. This is a completely misleading scenario. But if you looked at the median, right, what would the median be? Well, you would have 100, 100, take that last zero off, 100, etc., and you do this, 99 times, then you would have the last value of 90,100, but the median value would be 100. Okay, so the median here is equal to 100. Now 100 is certainly much more representative of this distribution of scores than this 1000 would be in terms of the mean. And so sometimes, what's the moral of the story? Sometimes is that the median might be a better representation of the data. Sometimes the mean might be a better representation. And when you see these kind of graphically, what might it look like? So if you have a normal distribution, I'll just kind of draw some real simple graphs here. The mean, the median, and the mode. So mode, median, and mean should be the central points in a normal kind of bell-shaped curve. We'll call a normal 1 here. What happens if it looks like this and it's bimodal? Maybe something that kind of goes up, comes down, goes up, comes back down again. Well, then over here you would have either a major or a minor mode, and then over here you'd have either a major or a minor mode, because remember here that your y-axis, which I haven't drawn in, I'll draw it in on this one, the y-axis would be frequency, right? So this is your highest frequency right here, so it would be mode, the most often observed score. And then in this particular case, the middle of this would be the median and the mean. What happens if you have something here that looks like this? We haven't talked about skewed, and we're not going to necessarily get in depth with it right now. It'll be for a different video, but let's say you have something that looks like this, where you have something that comes up high and then comes down like that. So it's asymmetrical. The tail over here on this side is much kind of longer. In this particular case, your mode, your most frequent score, which is still on the y here, frequency, would still be right here. So that's your mode. But then your median, the half the distance here might be just to the right of the mode. So let's just say median's there. And then it might be that your mean is even, to the right of the median here. I'll just put an X bar here. And the same could be true if you did this the opposite direction. And I'll just do one more basic kind of graph. And these are just to give you an intuition here. We're not putting real numbers in here, but this would be y. This is still frequency. And so now if we just kind of did something that looked like a long tail on this side and went up and down, and you might have your mode here, the median to the left of it now instead of to the right of it, and then the mean, the X bar here. And so I just want you to know that in real life we often don't get this kind of normal distribution right here. We get things that look bimodal. We get things that kind of are more skewed to this left-hand side. We'll talk about what these shapes mean later on when we get to the normal curve, or it could be kind of skewed over to this right-hand side. And when that happens, the mode's still going to be where the hump is, right, in terms of the frequency, but the median and the median and the mean will be to either the left of it or to the right of it. They're kind of getting pulled. And so that's just, again, a little statistical soul trying to give you kind of a good sense of how these might not always converge on the same point. Thanks for watching the video.